Okay, good morning, everyone. We starting with the new course that is reproducible research. This is the fifth course uh, in our sequence of courses that is there. Uh, so we'll just look at some of the concepts and the ideas in this course. So one key thing that is important for any kind of data analysis is replication. Somebody should be able to replicate whatever you have conveyed, right? You always come up with the hypothesis at the end of all of your analysis, so that hypothesis should be replicable. And what is the ultimate standard of strengthening a scientific evidence? When you say strengthening, basically verifying and validating it. It is replication of your findings. All right, somebody should be able to repeat it, replicate it. Okay, so and the findings typically are some kind of a hypothesis, like say X causes Y, etc. Right? N- how to replicate it? By with independent investigators. When I say investigators, independent scientists, right? So independent scientists, and then independent data. So same thing can be proved with some other data as well, right? And different analytical methods, say whatever techniques we use, finally it should get us to the same results. And different locations, different labs, let's say, right, different instruments. So even if we change all of this and still we can replicate the same finding, then there is more strength in our findings, right? And uh, so if the findings are true across all of these variables that are there, that is different scientists, different data, different analytical methods, different labs and instruments, then they're more robust and strong. All right. So, replication is particularly where is it more important? Where the findings have a lot of impact, right? Especially some policy making impact, regulatory decisions, where it can impact in a big way. So there it is very important to have replication, right? So this is a little bit about what is replication. Now, but what is wrong with replication? You just can't replicate all the studies because of the various reasons. One is time. So it, for example, some studies can take years to do, say 20 years, 30 years. So it may not be possible to replicate them, right? And second is the money that is involved in replicating the same study, right? So if we are talking about, say, at least four or five versions of the same work, say, that much amount of money, so it may not be possible to have that kind of money. Lastly, the study may be opportunistic in nature or it may be unique in nature, uh, which means that so if the study is opportunistic or unique in nature, means you can't really replicate it for various reasons, right? It's very unique. So then what is the alternative, right? So what's the alternative? How do you manage if you can't replicate? One is that you don't do anything. Second is you find a middle path. You find out, okay, what else can I do? Okay. So now, so what is this middle path? Is one end we have replication, and the other end we have nothing. So we say, okay, look, can we define a coin, and another term we say reproducibility. So what is that? Basically, we are saying make data of original study available. Whatever study that we did, we make the whole of the data available, and we also make the computations methods available. That is basically the programming, the code, right? In this case, right? So you make all the data available and all the computation methods available. So what is it that we want to do then? We say, okay, at least validate the data analysis that has already been done. Okay, so it will just validate the data analysis, nothing else. Though it is difficult to validate the question itself, so the question won't get validated, right? All we are saying is, okay, if I just you know execute these uh not audible. Wait, I'm not audible to any of you. Okay, I didn't get you. What did you say, Sarvani? We are able ashram article. Not you are nots. You're not able to see my notes. Is this what you're saying? Oops. Oops, 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 oops. Wait, wait, wait. Okay, okay, okay. Wait. Uh, all right. So now is it fine? Hmm. Oops. The Shastram article. Okay. Anyways. Okay. So so now when we're talking about reproducibility, you're saying that, so basically we will not be able to validate the question that is there, but we can still validate the analysis. Okay, so what's the need to even just validate the analysis? Why would you even want to do that, right? You say, okay, all it is doing is validating the analysis, right? So the simple answer is that today even the data analysis has become extremely complex, and even the validation of its correctness is important, right? So it is not straightforward. The code tends to be more complex, the data is more complex, so everything is so much more complex. So this is the reason why you want to even validate the analysis. Okay, and and why do we need the reproducible research, right? So we're saying reproducibility is the solution there, wherein we just provide the same data and the same code, and we say, okay, can it be repeated? uh, so we say basically it is because of the complexity, as we said, right? So the new technologies that are increasing the data collection throughput, the data is more complex and extremely highly dimensional, right? So there is large amount of data, the data is high dimensional, so multiple dimensions to the data. Okay, and next is existing databases can be merged into new mega databases. So there are huge amount of data bases that are available, we call them mega databases, right? Because of which again there is complexity that is getting added. Okay, and even the computing power is greatly increased, which allows for sophisticated analysis, right? So analysis themselves have become more sophisticated, right? So for example, for every field X there is a field computational field X these days, right? For example, we say computational biology, computational maths, computational chemistry, all these subjects are there in even in the universities, right? So the things are much more complex, and that's why we need to have reproducible research going on. Okay, so this much just enough on the theory front. Okay, uh, or let me quickly see what more. Uh, so we've done this, we've gone through this slide. So here these guys, I mean, these slides you can go through for the purpose of the quiz, they don't add much value. So for example, yeah, this is interesting. So there is something called a research pipeline. So what is a research pipeline? So typically when the author does the research, he starts from his measured data, right? And then there is some processing code that is involved, and this processing code prepares the analytical data, right? And then this analytical code that is there further will prepare the computational results. These computational results will go into three parts. One is the figures, another is your data tables, right? And then the numerical summaries, etc. All of these finally go into an article. Okay, and then you have text into the article, right? So basically, let's say you read a IEEE article, right? It's a research document, right? What do you read? You read the article, right? And then there are graphs, and then there are tables and figures in that stuff. So when a reader gets this research, he's going through it the reverse in the reverse direction. He gets the article first, he sees all these figures and tables and numerical summaries, etc. And then if he can get hold of the computational results, if at all, then he tries to kind of come to that, right? And so on. So he's walking the path this way, from uh, right to left, whereas the author is going from left to right. All right. So this is the research pipeline that is there, and so different kind of recent developments he's talking about in the news about reproducible results. Okay. Uh, So key things that we need for reproducible research, as we have seen, the analytical data should be available to us and the code should be available. And then there should be documentation of the code and data, right? And then there should be standard means of distribution. So how do we distribute it, right? And so who are the stakeholders here? One is the authors, right? So they want to make their research reproducible. So they want tools for reproducible research to make their lives easier, right? On the other hand, the readers want to reproduce interesting findings, right? Whatever they see, the findings, they should be able to at least run it, right? So, for example, you're reading an IEEE paper and there's some data there, right? Some table. If somebody had also provided you the data, you can actually execute it and you can also see the same results, right? So they want that the tools should be such that they make their lives easier again, right? So so what are the challenges involved in this now? Let's say somebody is giving you IEEE paper only versus everything else. So they need to undertake the considerable effort to put all this data on the web, right? Somewhere the data has to go on the web. It should be available, and then the reader must be able to download all these results individually and piece them together with different data, right? So all the sections have to be downloaded. This is one image, this is another image, this is so and so, right? And now the readers or the readers will not have that kind of resources. The author will have all the resources, right? So author has all the softwares, etc. The reader only has limited resources. So now, so then we need to have some tools that can help both the readers and the authors, right? So but what happens in the reality? In reality, authors put some stuff on the web. All right. Say, for example, say IEEE journals, etc., etc., etc. Right, and the readers will just download these data and they try to figure it out. Right. I remember my seminar project in the second year was just to read three IEEE papers, and each of these papers was just 4 page long. Right. Just so basically, I had to just read 12 pages of data, and I can assure you it took me many days to go through the details of this, understand what it is, kind of do backtracking, etc., to finally come up with what the document was actually you know saying. So there is a lot of effort that goes into this aspect. So what we say is there's something called literate programming, all right, or statistical programming, right? And what happens is, so it basically is a combination of both text and code, right? So the analysis code can be divided into text and code chunks. So the two chunks are there, and each code chunk loads data and computes the results. So what happens is, whenever there is code that is appearing, it will actually work on the data and will also get you all the results, and those results will also come in the presentation code format, right? So everything will be in one place. We will look at an example of this, right? Uh, so literate programs can be, so there are two parts to it. One is weaving it and tangling it, right? So weaving to produce human readable documents, all right, and tangling to produce machine readable documents. So one is the document that will be read by the machine, second will be the document that will be read by the humans. So one is called weaving, another is called tangling, all right. So so we say literate programming is a general concept. What it requires is one documentation language, which is human readable, and a programming language, which is machine readable, right? So different kind of programming languages can be used. Documentation languages can be used, like for example, LaTeX is there, R is there, right? And Sweave was developed uh, as a literate programming language, all right. Uh, so Sui was one of these languages. So, but there are limitations to this language, that it has, it's focusing mainly on LaTeX, and LaTeX is kind of little difficult to learn, right? And it lacks features like caching. Say sometimes your code is such that it'll take a lot of time to run. So your focus is right now just to reproduce the result and not run it every time. So you want to just be able to cache it. So that's not so easily possible in this, right? And it's not very frequently updated or very frequently developed. Where is the alternative? The alternative is Knitter, right? So Knitter is a more recent package and it's available within R. Okay, brings together many features that Swift has limitations on, and it uses R programming language and various documentations. For example, it uses Markdown, right? We have gone through Markdown as a language, right, in R. So it uses LaTeX as well as HTML, and it was developed by this guy called Yihui Sai, right? Somebody, anyways. So basically, we say that reproducible results is important as a minimum standard, particularly for studies that are difficult to replicate. Infrastructure is needed for creating and distributing reproducible documents beyond what is currently available. Then there's a growing number of tools for creating reproducible documents. So there are various tools that are available which are growing up. So this is what we have in the week one of the lectures. All right, and very quickly, let me see. So what is basically this knitter, right? I'll just very quickly go through this, okay? Kind of skim through it in 5 minutes so that we can then move on to the code, all right? So whatever I talked about now, you should be able to, what I would suggest strongly is you attempt the quiz one, all right, and then refer to this slide and you should be able to manage it. Okay, so as we saw, there are problems about things that are there, like we have to uh, do the text code, and then we've already gone through. So how do I make my work reproducible, right? We see, so various things are there, right? So Knitr is the key language here, and Markdown we already know about, right? And so what is Knitr good for? It's manuals, etc., various things. What is not good for very long research articles, right? We will look at it. Why is it so? And how you can execute it also we'll see. All right. So now, and then how do you process it, right? All these things we will actually do it as, either as a demo today or at least start it off. Okay. So we'll actually hands-on do this work. We don't need to go through this document in detail. Okay. Uh, it'll be faster to learn it by doing it hands-on. Okay. So let's get on to the hands-on work now. Uh, uh, Already? Okay. So what I'll show you first is mm, so we'll move on to the so the key thing that we need to remember is that we need to have both the e- English language part of it as well as uh, the code, okay, in one place. I don't know if you can read this. All right. So what we need to do is let me just give you a summary. In this project, there is some activity that we need to do. We have some monitoring data, all right, and in this data, we what we are doing is what we are supposed to do is we have to load and pre-process this data in some forms, okay, and then make some mathematical calculations, all right, and then draw some graphs, okay, and then what next we are going to do is we are imputing the missing values, which means whatever the missing values are there, we are adding some values there, and then again we plot the graphs and see is there any difference, right? And then in the end he asks for another question which says, okay, if we differentiate the patterns by another particular data column, how does the data look like? So basically standard questions that we typically will have in any kind of analysis, right? So and then we have to submit it. So this is where the learning from this course will come into picture, right? How we kind of make it, right? So we'll make, normally we are making an R file, right? Or we made an MD file. Here what we are going to do is we're going to make a RMD file, all right? And this RMD file, then we're going to use GitHub to submit, all right? So the key thing here is the RMD file, okay, which we are going to do. But so let me just show you the results of an RMD file here, okay? Uh, so now if you look at this document, all right, this document uh, on the so this is basically the output of my first project, all right. I guess it may not be very readable, so I made it slightly bigger. Is it readable enough? Readable enough for you now? So if you notice, this first line is English, right? And the next line again is English, and then I have my code here, all right. And so once I have the code, then again I'm saying something, then I'm executing a line of code, all right. And then again so with this line of code has been executed and this is the output of that, okay. Again then I'm executing this line of code, these lines of code rather, and here is my output. So I see lines of code, chunks of lines of code, and the output, all right. Again a chunk of lines of code and an output here, again line of code, output, again some English, all right. So what's the average daily pattern? So we have all this code and then the output corresponding to that code. Again, so this goes on. All right. So imputing missing values, as I said. Then I'm putting some English here. I'm saying, okay, what's my strategy? I'm going to do this. Again, I have the code and some output. All right. Then I'm plotting the histogram, right? Again, repeating. So my new line of code, and my histogram and so on, right? So this is how the document gets is the final output document, all right? And this is an HTML file. And how did this file get created? We created it using a uh, RMD document, all right? And so basically this is the RMD document that is there, okay? Uh, if you see this, all right, so this is what the document is. So to begin with, it may look a little bit overwhelming that what all is there, but as we proceed, we'll find that it's much more simpler. So now, so how do you basically prepare this document? So I'll give a very brief overview of this again, all right, and then we'll get into the code, and then we'll say, okay, how we can do this. Okay, so the brief overview is this. uh, let me so basically what we do here is, uh, if you notice on the top, this is kind of something standard, right? So this is standard as it is. This syntax would be standard from line number 1 to 7. Okay, so here you will just change your title. You don't need to bother about anything more. Okay, and you then have again say so this is the MD language, right? So two hashes that are there will give you a line of text. Okay, and then anything that I want to put in code, I put it using these three backticks. All right. So three backticks. Uh, let me do it on. Give me 1 second. Huh? So I'm going to write it. Let me show you. Um, okay. So what I'm saying is, then wait. Utkarsh, just a second, huh? Shared this. You mean to say share it, or are you saying shared this? You want me to share that the HTML file? No, no, no. I haven't yet. The whole idea was that I just make you go through it first, okay? And mm, because actually that is the output of the project that I have done, right? I didn't want to share it as it is. I thought it might be better if you guys have at least understood something and then you create it on your own. So that's why I haven't shared it. Okay. So I mean, I know you guys would put the effort, but there are some who would just kind of copy paste it. So that was the reason. Uh, but yeah, let me do one thing. I'll share this uh, document. It will not matter much because I'm not sharing the code behind it immediately. Okay, so let me send that as an email. Okay, so I have mailed you guys the uh, uh, okay. So now I mean, this document looked impressive, isn't it? When you saw that, how is it? that you have code and then you have graphs, etc., everything. I mean, to me, when I saw it, I found it quite impressive as wow. Eh, basically, that is what reproducible research output is basically. You have your data, then you have your code, and then you have your outputs, everything in one place. All right. Uh, but at the same time, it's very, very easy to generate it also. There is nothing complicated about it. All you need to do is this. If you wait, what happened to my pen? Hmm. All you need to do is basically uh, so so basically say normally what happens is we just keep on writing lines of code, right? So let's say this is my code. Now if I have to put text, then I put a hash and I put comments, right? So this is how my normal code goes in an R file, right? So now what I'm doing is I'm saying instead of these comments, I can use the wherever I need to use comments, I'll still use them. That is to explain the code. But when I want to kind of talk in English and explain certain other things, strategy and different ways of doing it, then I use English as it is. And this code, what I do is I cover it up in backticks and then I say bracket open R, bracket close, and then this is where my code comes in. All right, same piece of code. And then I close the section with three backticks. It's as simple as that. All I need to do is this much, this part, and that's it. So basically, I create code chunks, and then there are certain parameters that I can pass to this particular, starting point here, the code chunk, which we will see. But it is actually this is it. That's all. Nothing more to it. And this will create that beautiful document that you saw. All right. So is this clear? You understood what we have done? Okay. Let me quickly make you code walk through my code, and that'll make you understand what I mean. For example, if you notice this, right? So there are these first six lines of code, huh, which may sound that you don't understand anything, but that's all right. Okay, leave them. Okay, they're standard. Okay, then line number 9, if I see, I have two hashes. This is a MD code, right? So loading and pre-processing the data. And then I have three backticks R. Then I can give a name to this code chunk. So basically, this is the name of the code chunk. Load pre-process, right? And then echo is equal to true means the output. Do you want to actually see the output or not, right? So I can say echo is equal to true, which is what I need to do for everything, right? And then there's this library called knitter that I want to use. Okay. So I say library is equal to knitter. And then I have my lines of code. And then I close this. All right, so I've closed the three backticks. Then again I have my next chunk, right? So again I put uh, uh, two hashes or three hashes or one hash depending on how I want to show it. Okay, again my lines of code start, right? So this is one chunk of line of code. And why do I start another one here? Because after I do this, I want to show the output of this. All right. And so once that is done, then I start with the next lines of code. So this is where my next lines of code come, right? Here I've said warning is equal to false additionally because I don't want to show any warnings related with this in case there are any. Okay. So these lines of code go on till here, and then I have the three backticks. Okay. And so on. So again, I have some English and then the three backticks with an R, and then it closes. So this goes on till here, another chunk. So I can see all my chunks here. So whatever chunks I keep creating, so there are 8 chunks of code in my whole file, whole RMD file. Okay. So, and then all I need to do is I say knit HTML and it'll actually create the HTML file. I don't need to do anything. It will automatically create the HTML file as well as the MD file. Okay. So is this much kind of at least an idea is there with you how to go about it? Maybe I'll just do a. So my idea was not even to focus on RMD today. My idea was that we finish off with the coding of the project first today. All right, and then next class onwards we focus on this part. All right. So can we move? Can I move on to the coding part of the project? all right, which is what it has been always, right? Simple, nothing new about that. Okay, all the stuff that we have already done. But I feel that by doing more and more of these, we become more comfortable with using R with the analysis, etc. Okay, so what we will go through this quickly. Let's uh, look at the questions that are there. All right, so what is the program going to ask us? Okay, so we'll say, okay, we'll make the research reproducible. In the end, let's first write the code. That's how typically any researcher will do, right? He will bother about making it replicable once he has at least reached the concrete end to his whole research, uh, right? So so first is the activity monitoring data. All right, and so uh, let's look at this data first. Okay, uh, so here's my console. um, what's my working directory? So let me change the working directory. By the way, I'm using RStudio today. All right, I didn't find out quick way to get hold of this RMD file, knitting it using pure R, so therefore I'm using RMD. So my all right, so I say peer assessment one. All right, so this is my folder now, and now I have a file called activity.csv. All right, so ideally I should have just been able to, you know, read. So I want to read this file, right? Rather not what have been given to me is, in fact, activity.zip. Let me just see if that file is there, right? So what has been given provided to me is activity.zip. So one straightforward code can be, I say, uh, so I'm reading the file, right? So I'm executing the line number 12. All right, so I've read it. Now my raw data is this, so let me look at the raw data first. So I say str raw data. So raw data seems to have three variables. One is steps, is an integer. I see NAs everywhere in this at least. Then I have dates. There are factors with 61 levels. All right. And then there are intervals, right? 0, 5, 10, and so on. So I want to look at it a little more closely now. I want to understand this data a little more better. Okay. Uh, so what I do is, maybe I just say raw data. Individually, I want to see that, right? Raw data dollar steps. Let me say unique, all right, instead of this. So another way to understand the data is you pick up the rows and then you just say unique steps, right? And yeah. Hmm. So so I seem to have, as far as steps are concerned, there are some numbers there. All right. I see some numbers there, and I also see an NA, right? So there are some places where the steps would be NA, and some places where it is numbers. Okay, so this is for my steps. Now let's look at the other, let's say date. Okay, so it has 61 levels, and I see dates. Okay, but this is still, I think, a factor only. It is not really stored as a date. All right, so understand there's a difference between a factor and a date. Okay, all right. Next is, let's look at the third uh, data point, which is intervals. Okay, so if I notice this, what I see is there seem to be no NAs. It starts from 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and then it jumps to 100. All right, then 105, and so on. And again, what I notice is after 155, it jumps to 200, then 205, and so on. And it goes on till 2355. Do you think you can make out what it is? It says interval, and it also says this time intervals, and it is this seems to be an integer. Can you make out anything? What is the interval here? It says identifier for 5-minute intervals in which measurement was taken. What is this interval conveying? If you just look at it, Yeah, they're conveying the minutes, right? Basically, it's straight away. Basically, 7:05 means 7 hours 5 minutes, right? And then 11:45 means 11 hours 45 minutes. But just that it is represented as an integer. Okay, so that is what the interval is here. Okay, so now we have this data, and then we have, let's look at more of the data, right? We said there are about some 17,568 observations in it. All right, we've already seen this. I say str. You have you read this data in your files also? In your R? I sent you the file yesterday. I guess you must have executed this command read.csv. Okay. So now once we look at this, now what are we supposed to do? Right? So we will skip this part for now. We are supposed to create a single RMD file, okay, which will be processed by Nitter then and will be transformed into an HTML file, right? So and he says that in each of the code chunks use echo is equal to true. We will take care of that, right? And then finally we use the standard method of submitting it in GitHub. All right, so we will come to that portion a little later. Initially, let's just do the assignment part, right? So first part is show any code that is needed to load the data, then process slash transform the data if necessary into a format suitable for your analysis. Okay, so this is the first part. Okay, so what I have done is, so first part is reading the data is simple, read.csv, right? And then what I'm doing is I'm doing some transformations. What are the transformations? I'm creating another data set out of this. I say a data where I say na.omit. So omit all the rows or columns which contain the, sorry, not the columns, only those rows which contain na. So let me execute this. And now if I say str of a data, so this has 15,264 uh, rows, right? It has lesser number of rows. This has 17,000, some 2,000 odd lesser rows because wherever there was any, that has been knocked off. Okay. And now if I look at the data, I see that the number of steps that are there are, it does not have the NAs here. Factors are still 61. All right. Why so? Because factor doesn't change, but there might be some rates that have been dropped just in case. All right. How do we know that? So what I can do is this. One is uh, I convert the date uh, uh, into characters first. All right. I say so. I convert it back in I convert it into characters, and then I reconvert it into a factor, and then let's see what happens. Okay. So just notice here we had 61 levels. Okay. Now what I'm doing is I'm saying so I say as dot oops as dot character a data dollar date. All right. So if I do this, what is happening now is everywhere I see double quotes because I've converted it into a character. If I was to just say a data dollar date, I'd get a different result. I say a data dollar date. All right. So I'm not seeing these double quotes. Whereas when I execute saying as character, then I see the double quotes, right? Everything has been converted into a character. Now again, I want to convert it back into a factor. So I say as factor. Now in the end, this line shows that there are 53 levels, which means some of those dates have been dropped. Okay, because we executed the na.omit. All right, so this is just to show you that how the factor remains constant even if you drop some rows of data, and the data may not even be there, so you may want to refactor a column. All right, so what we did is I refactored the column, so which removes all the dates corresponding to the na values. So now I have two data sets, one is raw data, another is a data, right? In the a data I have uh, converted something into a factor as the date is concerned, and then I've removed the NAs. Is this fine so far? And this point is also very, very clear because for me it was I mean, I just accidentally happened to get to understand this, that the factors won't change because I was comparing some results at the end and I found that there was something that was not matching, and then figured out the reason was that the factors were different. All right. So is this point very clear? The factors, even when say once you created a factors, right, those factor levels will stay the same, okay, unless you refactor it. Even if you delete data, the factor levels will still continue to be the same. Why first to character and then to factor? Yeah, a little bit confused because factor is like, you have some data, let's say, right? Either numbers or characters. When you add factor to it, what will factor do? It will pull out all the unique values and create a list and make each of those as levels. Okay, so let me show it to you here. Okay, so now, so let's say I have some data, all right, and then this data has data 1, data 2, 3, 4, again 1, 2, 4, 9, 6, and so on, right? So whatever are the unique values here, say it's data 1, data 2, 3, 4, 9, and 6. All right. So let's say that these are the unique values, and this may have 100 records. All right. Now this has only 1, 2, 3, 4, 5, 6 records. All right. So now when I factorize this, all right, good question, Utkarsh. Maybe let me just give a brief overview. What do we have to do with the activity data? Uh, Basically, what we are doing is basically it is again as it said. What is this data? Let's understand this first, right? It is the steps that are taken by people. How much have they walked? Let's say, right? How much did they walk at different time intervals during the day, right? And then different dates. Let's say you're wearing some kind of a instrument which measures how many steps that you've taken. Is this right? It's like people who are walking, right? So that is what this data is, right? And so there are two objectives to it. One is, let us look at, forget about reproducing it for now. Okay. What I'm doing is I'm saying, okay, this is what I have, and I want to analyze this data, right? I want to see the daily activity pattern, how people have walked, when they walk the most, right? When they walk the least, all right? And then I want to see uh, how my data changes if I, change the missing values. Then I want to see how the activities change over the weekends from the weekdays, right? So this is what I want to analyze. This is what my objective is, and at the same time I want to reproduce this research that I'm going to be doing. Is this clear to you guys now? What is the objective of this particular assignment? Okay. All right. So it's always best to first understand the data, STR, and then unique values will help you to look at the data first. So now coming back to the question that Jatin had, which was that how do the factors work, right? So the factors, right? So I have six factors. So I have 600 data points, six factors. All right, based on unique values. All right. So for example, I had data which says male, female, right? Male, female, male, male, female. So my unique values will be just male and female, right? So I have only two factors and I can have any number of data points. Now what I'm doing is I'm saying what from the data, if I ended up deleting certain rows, let's say I ended up deleting these rows, okay, which had 9 and 6. Now what I will see is that even if I end up deleting these rows, if I look at the factors, it will still be these six factors available. I will still have 9 and 6 as factors. They would not go by on their own. I've just deleted the data. I haven't changed the factors anyways, right? So, and they are kind of redundant factors for me right now in this scenario, all right? So I may want to refactor the data, right? Refactorize. How do I go about doing it? I want to remove the factors from this data first. So this is my data. How do I remove it? Say, for example, there are different ways. So I can say as fact. So how do I want to store my data? I can store it as a number. All right. In which case the command will be as numeric. By default, the data will assume some uh, data type, or it can be as character or as factor. All right. So the first thing is whatever was stored as a factor, I want to convert it back into a character. In which case, so the data gets converted into a character, and then again on this, when I apply the as factor, I will get the new set of factors. Is this clear now, Jatin, and maybe to the rest of you guys also? What is the whole idea of redoing the factoring? And when I do the refactoring, what will happen is my new factors will have only four values: 1, 2, 3, and 4. Guys, is it clear? Why did I do that refactoring? Now, again, this was not essential for the assignment, and that's why I don't want you to just straight away copy my code. This is what I found. I wanted to do something, and I kind of added that line of code. All right. So, so this is my pre-processing. I wanted to do this for a date data for. So basically, if I see my raw data now, if I say str of raw data, I see that there are 61 levels for the date factor. All right. On the other hand, too much lag, is it? Is it that only Pratik is getting this lag, or the rest of you are also getting it? Which means I can at least kind of isolate the problem. Is it happening from over transmission level, or maybe the receptor side? Jatin is getting no lag. Jatin is also in the hostel. Okay, which means so it is all of you guys are in the hostel only. Okay, so Pratik, it might be due to with how your net is connected on your machine. Okay, all right. So the factors part. Okay, that means most of you it's fine. I see Pratik that most of them, the rest of the class has it fine. I guess you may need to just disconnect and reconnect, or I don't know. Okay, three of you are at Raghav's room. All right. Hmm. So now if I was to do the str for a data, all right, then I see that the number of sorry, I haven't executed this line, right? So I haven't executed the line number 14. So let me execute it first. Once I'm done with that, okay. Now if I say str of a data, what do I get? I have factors which are 53, just 53 levels now. All right. Some of these dates have been removed because you notice we had na.omit. Because of the virtue of that, some dates have been removed where there was no data. Is it clear now? What has this as factor done? So this was my pre-processing part, right? And once I'm done with that, the next part is, so let's look at what I'm doing next. So what is the mean total number of steps taken per day, right? This is what I want to do. So for this part of the assignment, he says you can ignore the missing values in the data set. I have already done that. I have taken in the loading and pre-processing of the data, I have created two data sets, one where I have ignored all the missing values and one where I have kept the data as it is, right? So he says make a histogram of the total number of steps taken each day. Now this question, uh, okay, tell me, first of all, what is the processing that I need to do on data? It says total number of steps taken each day. What do I need to do? So sum all the steps of a day. Perfect, right? So which means I need to group my data and I need to summarize it, two parts, right? I have to group it by what? Summarize the steps for each date, right? So I have to summarize, then I have to group it by, right? So I need to group it by date and then summarize. The summary function that I need to use is sum, right? So I say group by date and summary is sum. So I'm using dplyr, right? So simple code here, right? I say a data, then we saw this in the last uh, class also. We say percent dot percent. So my a data, that data I want to group by date. I'll say group by date, then again percent dot percent, and then summarize. And I give a new name to the column that will be created. I call it total steps, and then I say is equal to sum of steps. Now here also I'm mentioning na.rm is equal to true. As such, it is not required because I've already knocked off all the NAs from the data. But just for sake of completeness, I'm mentioning that na.rm is also equal to true. So I do this, but before that I'll have to do library as dplyr. Let's see what if I don't do that. I'll execute this line of code. Okay, so I'm executing line number 21. It says could not find the function percent, right? Why so? This function is a part of dplyr. So I execute this line of code. All right, so I executed that, and then now again I execute these lines of code. So when I execute it, I have this data which is DQ, data for question 1 part A. All right, DQ1A I got, right? So if I want to have a look at this data, I said str of DQ1A. All right, so what do I have here? I have a date, factor levels how many? 53. All right, total steps. So 53 observations are there. Overall, there's 53 observations and two variables. Maybe let me just have a look at this data as it is. So I can say DQ1A. All right, and what do I get? If you notice, so I'm getting the date and the total steps. For each date, there are total number of steps that are there, right? All right, so what do I need to do next? So I have got this. Now it says make a histogram of the total number of steps taken each day. What do you know? What do you need to plot now? Tell me. He says make a histogram. So what do I need to plot? So give me an idea. What do we need to plot here? Date versus steps. Kaustubh says date versus steps. Question says make a histogram of the total number of steps taken each day. Plot the steps versus date. Jatin says the same. Kaustubh says okay. No, no. What function we will use? I don't want that for now. Just tell me what you plot for against what, right? What will be your x-axis? What will be your y-axis? So what will be your x-axis? Okay, Jatin and Kaustubh have already answered. I'm waiting for the rest of you also to answer this question for me. Utkarsh, Supreet, x is date and y is steps. All right. Y-axis will have the number of steps taken. X-axis will have the date. So Mayank says steps versus date. All right. So Sarvani says x-axis will have the day. All right. Hmm. Raghav says date versus step. All right. Whoever has not answered, I'm waiting for your answers. I still see some of you not answered. Come on, give me some answer. If you don't know the answer, that's okay. Mention you don't know the answer. I'm anyways repeating everyone's steps on the y-axis. All right. And what is on the x-axis? Date. All right, Utkarsh. All right. So anyone else who's left? Kaustubh has answered it. Mayank has answered it. Pratik, Raghav has answered it. Sarvani has answered it. Supreet has answered it. Utkarsh has answered. Dheeraj, Devashri, Chandramauli. Okay. Don't know. All right. Date on the y-axis. All right. Let me repeat the question. What was the question? Make a histogram of the total number of steps taken each day. Yes? Is this clear? So the question is make a histogram of total number of steps taken each day. Let us quickly have a look at our data first. What do I have in the data? Final data here. It has a date column and it has a total number of steps taken each day, isn't it? So I have two columns. Each of you gave me the answer other than Chandramouli, who said he doesn't know, is that we are going to be using both these columns. Tell me one thing. Histogram uses one column or two columns? Histogram uses one column of data or two columns of data? Histogram always uses one column of data. Histogram creates the x-axis and y-axis both from that one column because histogram is about frequency. So what you answered me was the bar graph, right? A bar graph will have maybe the dates on the x-axis and the number of steps on the y-axis. But a histogram is just always going to take one single data point, all right, single column of data, and then create frequency chart out of it, right? So we want to draw a histogram. We don't even need to bother about the date. The date part has already been taken care for by the each day part. So a lot of people in this assignment have made this confusion and have drawn wrong answers. All right. So I'm upfront, making you aware about it. So I would be now plotting the histogram and not the bar graph. So let's look at my what's the code that we have there. All right. So my histogram code is this. So I'm using the second column, that is DQ1A. Second column is what I had computed, right? And so let me just uh, do this straight away. I say histogram or DQ1A dollar total steps. Let's see where our histogram went. Oops, what happened? Uh, I have been using R for all kind of plotting, and this thing works straight away fine on the RMD file. But if I was to see the histogram here, any idea how where it will show up? It does not open another. Where's my GR device? Any idea about the GR device for R? Sorry, R Studio. As I say this, where is my output showing up? Okay, here. All right. So, so this is what I get. So I have a DA1 total steps. So the total steps can be 5,000 or 10,000, 15,000, 20,000, 25,000, right? And then this is the frequency. How many times this has happened? So it looks like so this is how the graph grows. You can create more breaks in this. That's your choice, right? Okay. So is this clear? This is what we want. So we can decorate this histogram however we want to. We want to change the labels, right? Maybe the x-axis label as well as the title, and maybe give it some color. So what I'm doing here is, so I say x label is this, total steps per day, y label is number of days, right? And the frequency of total steps in a day is my main title, and then I make the color as red. So I execute this now. So I pick this code and I execute it. All right. So I get a new graph. Is it clear so far what we do? So we've answered the first question. I say make a histogram. We have done it. Now it says calculate and report the mean and median total number of steps taken per day. So first thing is calculating it, right? And then reporting it. So my mean steps is what? I can say mean of this and then remove. Let me just do this, right? I say mean of DQ1A dollar total steps. Okay, so I get an answer. And I have the option to pass on this parameter. I say na.rm is equal to true. Why do I need to do this? Because in this case, anyways, I have removed the NAs. But otherwise, let's look at this. I say mean of C NA comma 1 comma 2 comma 3. All right, what do I get? NA. If there is one NA introduced in the data, if I take the mean of it, I'll get an NA. But if I say NA.rm is equal to true, by default it is false. Then I get the correct answer. Same with the sum. If I say to knock this off, so I'm using going to use the another command sum. All right, so mean is fine. Let's see what happens with sum. Even the sum does behaves in the same manner. And then how do I get rid of it? I'd say na dot rm is equal to true. Now I get the correct answer. Same with median. Is it clear? What I need to do? I need to say na is equal to na dot rm is equal to true. Though as such for this particular computation here I don't need to, because I have already removed all the nas. All right. So I store this value in mean steps and median steps. All right. So and then actually there's a better way to do this reporting part. So I have calculated it. Computation part is done, and then the reporting I can do either using the print statement, or for example the sprintf, what I've done here, right? So I can so I have used this. What I will do is I will also show you some peer reviews that I have. Once I finished my assignment, I had the opportunity to review other students, and I found that some of them have done a better job in this aspect than me. All right, they have reported it in a better manner. Okay, so what this how I have reported it. So I'm just showing you what I did. So reporting part is this. I say print as printf, then percentage f is percent float. All right, so I can keep on adding. S printf is more like wait, it's a unique C like command. Where does the whew, uh, basically in this R Studio, the limitation for me is that I can't separately open the windows. Is there a way to kind of knock off the boundaries that is the R Studio creates in Mac? I know it's possible. I think in Windows, the pane layout that is there. So I don't want the pane. Sorry, Windows. Windows, it is possible. Mm, in Mac, I think it is not possible. It shows up in one single thing, and then you have to kind of. I can't change the pane layout. I mean, it has to. It sticks in this four. Windows Utkar. Sorry. No, no, Utkarsh, in Windows machine, the RStudio is different. In Mac machines, they are different, slightly different build. I mean, I just can't separate it. That's the problem. I don't have that feature here. Hmm. Okay. Uh, uh, view. I don't have. Okay, here. Go to Windows option. All right. Yes. Now next. All right. So I'm in the Windows option. What do I do there? Bring all to front? No. Yeah, I'm in the Windows option. You mean to say in the preferences? Is it there in the R preferences or in the menu bar? Yeah, I know it doesn't have it. That's the reason why I kind of moved away from RStudio. All right. So what I'll do is for this part of the code, let me just get back to R. All right. So it becomes easier for me to kind of show you when I have to come back to uh, um, when I have to come back to uh, RMD, I will come back to R. All right. For now, I think this is good for me. Uh, Let me just change the working directory. All right. So I say read.csv activity.csv and I read it into raw data. All right. Um, Let me also open the MD file. Let me just open this. So we're not touching anyways the, so I'm not going to be showing you this RMD for now. All right. So I'm just focusing on the code part. All right. Okay. sprintf. All right. So what is that sprintf doing for you? So basically, it's a wrapper for a C function called sprintf, right? So basically, it's a C function where you specify the format. FMT is the format, a character vector of format strings, each of up to 81, and then you specify the values, comma dot dot dot. So how it basically goes is something like this. So basically, I can have D, I, O, X, X, and X. These are all integers. F is float, all right. E is exponential value. G is double precision. Okay. N is S is character string. Percent will be the literal, which is, so basically you. So let's look at some of the examples here, right? For example, I say sprintf percent f pi. All right. So what I'll get here is, so it'll print the value of pi. All right. So if I say this, so I get this. On top of that, I could have written my value. Oops, my value of pi is. Do you get it? So with this percent sign, I can add and I can do this now. For example, percent this and percent I, let's say, right? I do this and then in between I say this something. Now for this again, I'll get an error because I haven't specified I, right? Too few arguments. So I say comma pi, comma, let's say another pi. Okay. Invalid use format for numeric objects, he says, right? So I say, let's say 45. Are you getting this? So is this clear how sprintf works? I can specify some, say I can specify percent s, all right, and I can say you got it. Is this clear now how it works? Basically, I can have one string with some string literals, some variables within that, and each of those variables in one sequence I can specify it and I can create a command which is like say sprintf, right? So I can use that command here. Is it clear what sprintf does? So it allows me to combine variables with text. Jatin, is it clear to you now? Okay, all right. So basically what I'm doing now is I create a sprintf and I do this way, all right. Okay, now you know what, I used straight away the dplyr, but I found out that there's another way to solve the same thing, little more tricky, but it will allow you to understand tapply very nicely. All right. So I mean the whole idea of of doing the projects now, because we start straight away from day one, is that we learn some other things also about programming, right? So even though you can finish off your assignment just by using the dplyr, I thought that this was a little more uh, complicated way to do it, but at least it allows you to understand tapply better. All right. And how does the output change? All right. So what we will do is we will look at this in the next class. Okay. I'm going to stop here today. What I'll do is I'll send you this A1 code. All right. A1 code I will send you. Okay. And I will request you guys not to, when you're doing your assignment, don't just copy paste this code. Okay. It will not be very nice. You should do it on your own. Okay. So basically, that's a trade-off. I can share my code with you as long as you don't copy it straight away for your assignments. because otherwise the learning doesn't happen. Secondly, your code may get reported as a copy paste, right? So you may end up in trouble afterwards. So how do you want to do it? But I still want to share it because I feel that the learning is always much faster when you have a code walkthrough, right? So you already have something, you just walk through it and you ask questions. Why is it like this? Why is it like this? And then you kind of figure it out either yourself or you come back to class and I answer it for you. So I will share the code with you and you go through this code. What we will do is we'll continue with this in the class on Wednesday as well. Okay. Sorry, on Thursday. Okay. So our next class will be on Thursday and we'll go through this whole code and in the end hopefully yeah on Thursday itself we should have finished this in class, all right. So we would have done the assessment number one, assignment number one. Okay. uh, so this is the plan. What I would recommend is you take the quiz one today. It's very simple. You keep it open book. Just go through whatever I have initially told you and take the quiz. And anyways, you take. I would say start focusing more on the projects because project is where the real learning is happening, and the quizzes kind of ensure that you remember the concepts. So you take the second attempt of the quiz. By that time, you would be, if suppose you make some mistakes, take a second attempt so that you have corrected whatever mistakes you made. Is this fine? You understood what how we go about it? So that most of your time goes into doing the project, which is hands-on. All right. And the quiz is more like, okay, it's more like a self-evaluation and you figured out what you didn't know and you re-verified and checked your answers. Right. So that'll be best way to do it because even if you answer it correct today, you'll tend to forget. But whatever we are doing in the projects, there is no chance you will forget it, especially if you've written the code on your own. Okay. So so that is the strategy that we will follow for quizzes. And the strategy for projects is that okay, we start working on the projects from day one itself every week. That way, the amount of time that you will need will be minimal. Secondly, it will become more interesting. Okay. All right. So let me just quickly, as I finish, I will email you that. Okay. So we're done for today. I have a I have been invited to give a talk at a college, so I have to get ready. I have to do my kriya, so we can't continue anymore. But this is good. I think even if you guys who are there in the lab, everyone else is in the room. I think maybe we can start off with the trend of sitting in the room. Is it? Is it good? How's it? Uh, that's fine, right? Saves a lot of time and so I think it's good. Then you can't have an excuse. Yeah, huh? And I think this software is working out very well for us in all aspects. Please, I will request you guys to bring in the rest of the class also, because I think it has become much more, it's always a starting problem that we have. We face some teething problems in the beginning, and we've kind of actually cracked it how to kind of go about the classes now, right? So that it consumes minimum time and we have maximum output. Being in the class, you know what I would suggest, you can come to the class but at the same time maybe you can sit in groups. For example, I think Jatin and some of these guys, Raghav and all, they're sitting in one room. So three of you sit in one room, right? Okay, yeah. So, I mean, I'm not saying that you guys stay in the room. All I'm saying is those of you who are not coming to class just because it is taking time and all, and then you have to get, you dress up and then you have to come. At least attend the class from the room, right? So can you guys encourage the rest of the people also to at least start attending class from the room? And slowly, when everyone is back into track, then maybe they can start coming into the classroom as well. Hmm? Okay, so each of you take responsibility for your group members. Okay. I don't see many secondary rights today, I guess. Jatin is there, then Raghav was there. I didn't. Okay. Raghav has gone offline, is it? What happened? Good. I think we will proceed this way. You don't have the project, right? So, what I'll do is maybe I'll send you. How do we go about it? You will not have access to the project, isn't it? How do I send it to you? Maybe I'll save the file and I'll mail you. I'll uh, save the page as. Okay. Bye. Bye, Raghav. Jai Gurdev. Uh, mm, okay. So that's it then. Good for today. Uh, and make sure that you guys have finished your previous course. All everything that is pending, keep finishing it off. Okay. The fourth course, make sure that you don't have anything left. You have taken care of the both the assignments and the quizzes. All right. Okay then. Bye, Mayank. Jai Gurudev. Yeah, you can't give the quiz. What I'll do is maybe I will share the quiz questions with you. Okay. You will kind of just go through it now, or we don't need to bother about the quiz for now. Maybe let's focus on the projects. All right. And when you register on December 1, that time you can take on the quizzes. Right. That'll be better. Okay. So, all right. Uh, Bye everyone. Jai Gurudev.